Now we shall check out the second approach, which is the fitting the average profile. Data points are averaged at each point in the measurement sequence. Measurements must be made at the same time across individuals. The average points across time are then used to fit or produce estimate for the pharmacokinetic model. Okay, so that means your measurements have to be made at an exactly same time across all the individuals. It also means you have to measure all the individuals at same time. If you have some missing information, this approach cannot be used. The average points across time are then used to fit to produce a PK model. Okay, now as you can see over here, the red points are the average of all the concentration measurement across the 5 simulated individual, like for example. And so doing this, for fitting the PK model to this average, we are ignoring the individual contributions. We are ignoring the uncertainty of the individual contributions. We are saying that the average given to the time point for that concentration is sufficient statistic to describe the profile, and if we do least square maximum likelihood fit, we got this pink line. Underestimate the last few points. So why not knife pooled or averaged approach? So we talked about principles of comprises of population model. We can only get at the central tendency. Okay, with both knife pooling as well as with average fitting, we are only considering the central tendency. Okay, both with knife pulling or with fitting average curve. And as we see from this table, we have the true values, the value from which the PK profile was simulated. In this case, clearance is 20, volume of distribution is 108, and Ka, that is the absorption rate constant, we got it 0.84. We see the estimates for knife pooled and average fitted are systematically. Even the curves fit reasonably well. A few inter like which the parameter had some physiological relevance, we get a parameter that may be skewed. So in this case, true value is 20 and underestimated is 14, being the return result of both knife pooling and average fitted. So underestimated clearance 75% of the true values, you can see. A corresponding increase in estimation of volume compensate the same curve. The value that was used for simulation was 108. Knife pooled value is 150 and average fitted value was 150 as well. Similarly, for the absorption rate constant simulated from a true average of 0.84 that we got from knife pooled is almost 50% higher, and the average fitted value as well. So we are interested in retrieving even the central tendencies. They are supposed to be possibly that you can have bias. In that we got interest in the issue of variability between subject variability and inter individual variability in this case. Okay, so we are not getting relevant results. The true value are different and the knife pooling and average fitting value are different, because here we are taking into consideration only the central tendency. So we